So in this problem we are given a regular tetrahedron with triangular base and triangular sides. Each side of the tetrahedron is made out of wire that has a resistance of 10 ohms. The question is, what would be the equivalent resistance between any two vertices of this tetrahedron? And what will be the current flowing in the battery if we connect a 12-volt EMF to any of two vertices of this tetrahedron? Well, let's say that we take these two vertices, let's call them A and B, and we want to find out what is the total equivalent resistance between these 2 points. So let's say that we connect an EMF here, like this. Now, if you think about it, there is some symmetry in this problem. And because of that symmetry, the electric potential at this point and at this point, these electric potentials are exactly the same. But if the electric potentials at this point and this point are the same, there is no current flow in this part of the tetrahedron. So we can get rid of that segment, so we can just erase it, and then the picture simplifies. So then these two parts are now connected in series. So we have two elements connected in series, so they add up to give 20 ohm resistance. So I can just erase them and say that I have a 20 ohm resistance here. So this is 20 ohm. I can do exactly the same thing here. These two 10 elements are in series, so they also add up to give 20 ohm. So another 20 ohm. So we now have three pieces of wire connected in parallel. 20 ohm, 20 ohm, and 10 ohm. So now we can calculate the total 1 over R equivalent. They're connected in parallel, is equal to 1 over 20 plus another 1 over 20 plus 1 over 10. So 1 over R equivalent, 1 over 20 plus 1 over 20 gives us 1 over 10. 1 over 10 plus another 1 over 10 gives us 1 over 5. So the equivalent resistance is 5 ohm. So we know the equivalent resistance, and we can now calculate the current in the EMF. So the EMF is 12 volts. So the current in the EMF would be 12 over the equivalent resistance, which is 5, and that gives you 2.4 amperes. So the important point in this problem was to realize that because of the symmetry of the problem, if you take any two vertices, for example this one, and connect an EMF to them, then the electric potential at this point and at this point are the same, and therefore this part of the tetrahedron can be ignored. Okay?